Hi, my name's Mark. I'm here to help you with all your GCSE and A-level math studies. The aim of this stream is to help you with as many problems as possible. But firstly, today's and this week's topic is recurring decimals of the GCSE course. We will discuss different topics and A-level questions later, if necessary, from the chat. But I would just like to do a few starter questions and then do a couple of recurring decimal questions to get us started. The main point of this GCSE course is revise the different high-level topics, and recurring decimals is a topic on the GCSE high-level specification. It's usually aimed at people aiming for levels 6 and 7 on their higher tier. So let's have a look at some of these starter questions. Feel free in the chat to throw out any questions to see if you're correct or answers to this question. Right, so the first things first, it says simplify the square root of 80. So, those that are well aware about the higher tier, let's discuss the square root of 80, and we need to write it in simplified form. First things first, to square root an integer, it needs to either be a square number or try and find the highest common square number that is a factor. So what I would suggest you do is look for the square numbers that are factors of 80. So first of all, let's list the square numbers. Because the idea is the square root of 80 is a decimal. If you try doing it in a calculator, it would be a decimal. But we're trying to make it into, yes, you can make it into a smaller number times by a square number, because then you can square root the square number. So let's list the square numbers. 1, 4, 9, because that's 3 squared. Then you do 4 squared is 16. And then 5 squared is 25. You carry on if necessary. But 49 will not be a factor of 80. Neither will 64. 36 is not, 25 is not. Now you could choose 4 because that is a factor of 80. But so that you don't have to simplify again, try and choose the highest factor of 80. So 16 would be the highest factor of 80. So once you know the highest factor, what you would do is write root 80 equals, and you can write root 80 as 5 times 16, because 16 times 5 is 80. Then you would write the square root of 5 times the square root of 16. Or you could write that in a different order. You could write the square root of 16, the square root of 5. The reason why you are doing this is because you can find the square root of 16, and that's a nice whole number. We know the square root of 16 is 4. But you cannot simplify root 5 any further because it does not have a square number that is a factor of 5. So 4 root 5 would be your answer. Let's go back to the next question. This one is actually volume of a prism, but it uses sectors as well. So to do this question, this would be a very harder question on the foundation paper because it uses level 4 and level 5 material. So, if you need the volume of a prism, remember to find the volume of a prism, you find the cross section area and then you multiply it by the length. So here the cross-section area is the area of the sector. So we need to find, because it's the sector that's repeated over and over again, if you like think of layers that are sectors here, they would repeat over and over again until they make up the entire prism. Now, to find the length of a sector, you need to do the area of the full circle. That's a formula you need to remember off the top of your head. And then you need to find the fraction of the full circle. So it's the angle out of 360. 360 degrees is the full circle. If it was 90 degrees out of 360, that would be a quarter, which is why it would be a quarter of a circle. And then you times it by its length. Right. So let's say we didn't have a calculator on this question. What you would do is do 2 pi. There you want. Okay. Remember, 2 pi r is the circumference of a circle. To find the area of a circle, you do pi times, what is the radius here? It is 12, because this length here that I'm going over in blue is labelled here, which is 12. That's the distance from the centre of the circle to the outside. So that will be pi times 12 squared. And then you times it by the angle of the sector, which is 72 degrees, out of 360. Then you times it by the length, so how often that sector is repeated. This one's sort of a prism from top to bottom, so it would be repeated 20 centimetres. So you times it by 20. So you've got a lot of calculations to do there. Let's see if we can simplify it any further that you may be needed to do on a calculator, or without a calculator on the non-calculator papers. Let's do pi times 144, that's 12 squared. 72 is actually 36 times 2. All I'm doing is trying to simplify that fraction as much as possible. Because if you notice, I'm trying to do it without a calculator, you would, the 36 over the 360 disappear or cancels to 1/10, so you're left with 2 over 10 when you divide top and bottom of that fraction by 36 times 20. Okay. If you want to do 144 pi and then times it by 2/10 of 20 is 4, because what you've got is 2 times 20. Remember, when you're multiplying together and dividing, it doesn't matter which order that multiplying and dividing you can do it in, but it does if there's an add or subtraction in there. So the 20 over 10 actually cancels down to 2 over 1. So that's why it's 2 times 2 at the end. So you've got 144 pi times 4. 2 times 2 is 4. And then you can do a bit of long multiplication to see how many pi it is. Okay, 144 times 4. 4 times 4 is 16. Add the 1 is 17. And then 4 times 1 is 4, add the 1 is 5. 576 pi. Now obviously that can be done in a calculator. If you do 576 times pi in a calculator and round it to 3 significant figures, that would be how you get your answer on a calculator paper. But here I've done it the non-calculator method. You need to be familiar with both. Right, so that's a couple of start questions. What we're going to do next is going to do an example of this week's topic, which was called recurring decimals. Right, so this is the one you've probably all been waiting for, because this is the question that was on the Instagram page to advertise this week's topic. So let's see if we can get this correctly calculated. So this is the type of thing you will do, or you may get on the harder, higher tier papers later on in the higher papers, because it is aimed at level 6 and 7 students, so it won't be in the first 8 questions or so. It will be towards the end. So let's do x equals, the idea here is if you see two recurring decimals, times, divide, add or subtracted, you can't do it straight away in recurring decimal form, but if you convert them to fractions first and then do a division of fractions here, you will be able to calculate the fraction itself. So x equals 1.818181. Now the recurring part is of length 2, so you need to move the decimal point twice, so that's why I'm going to choose 100x, and 100x I'll write above. 100x would be 181, so 181 point, and then you would have 818181. The idea is what you're trying to do is line the recurring part up, so when you come to subtract them, they all disappear to leave a terminated decimal. 100x take away x is 99x. Everything after the decimal point here goes to 0, which is good, it terminates. And 181 take away 1 is 180. So 99x is 180, and x equals 180. When you divide both sides by 99, 180 over 99. Always be aware, can you simplify it? So if we look at this one, can we simplify? Well, there's a 9 in the numerator, and if you're not sure how to do that, try and split it up into prime factors. So 9 times 11 on the denominator, 9 times 20 on the numerator. And you can see there's a 9 as a common factor on the numerator and the denominator that you can divide both by 9. So here you can write 1.81 recurring, and you can write it as 20 over 11. Now I'm not going to write that as a mixed number yet, because as we know, when we come to do add, times, divide, take away of fractions, it's best to convert them into improper fraction form first and then convert them back at the end. So I'm going to leave it as 20 over 11 for now. Let's do the same for 0.409. So let's have a look at that. So x equals 0.409, and or if you don't want to write x, you can write y if you want, because you've already used x earlier on and it can get confusing. But it's only the 0 and 9 that's getting repeated here, not the 4, because the dots are above the 0 and 9. Now, this is where some schools teach it slightly differently. Some schools like to do 1000x and then 10x and take them away. I find it easy to remember. So because the recurring length is length 2, you only need to move the decimal point twice. So I'm again going to use 100y. But you may just need to manipulate the fraction at the very end. They accept both in the mark schemes. So let's do 100y. That would be 40 point. And when you move the decimal point twice, the first thing after the decimal point would be the 9 now, which doesn't have to be the same as below it. But then after the 9, it would be 0909. So even though when you come to subtract these, it won't make it a terminating whole number, but it will make it a terminating decimal at some point. So again, you do 99y here. Everything from the second decimal place onwards cancels now, so they become zeros. But the 9 take away the 4 actually becomes a 5 here. So you're left with 40.5. So here you've got 99y equals 40.5. Right. So when you come to divide by 99, it's not exactly a fraction, okay? But you can manipulate it into a fraction by, I would usually say times top and bottom by 10 to move the decimal point 1 to the right. But because it's a 0.5 here, to leave the numbers as small as possible, you only really need to double it. Because when you double a 0.5, it becomes into a whole number. So if you double the numerator and denominator, 40.5 times 2 is 81. 99 times 2 is 198. You can do a bit of long multiplication if necessary for that. Now all I would suggest is try and simplify that as much as possible. And how you would check if it can be simplified is 81 is 3 times 3, that's 9 times another 9, so 3 times 3, so like so. And 98 is 2 times, it's 2 times 99, so 9 and 3 times 3 times 11. 3 times 3 times 11 is 99, then double it to get 198. And if you notice, there's a 3 and a 3 in both of them. In other words, there's a factor of 9 in both. And then there's no other common factors. So you would have 3 times 3 is 9 on the numerator, and 2 times 11 is 22 on the denominator. So what you have to do here is we are dividing them. Okay, so we need to divide the two numbers. So you've got 20 over 11 divided by 9 over 22. Remember, when you're dividing fractions, you use the KFC. It's not KFC actually, but people remember the chicken shop. And it's KCF. So you keep 20 over 11 as it is. You change the divide to a times and flip the second fraction, 22 over 9. And you can times them two together. Now, if you're trying to simplify it as much as possible, yes, you can do 20 times 22 on the numerator. But if you write that as 2 times 10 or 2 times 5, and then the 22 is 2 times 11, that's absolutely fine. And then on the denominator, you've got 11 times a 3 times a 3. Thinking about the prime factors shows that if there are any common factors, and as we can see, there's 11 in the numerator and the denominator. There's no other common factors, so you can't cancel any further. So 2 times 2 is 4, times 5 is 20, times 2 is 40, and 3 times 3 is 9, and that's as simple or as simplified as you can get it. Because it's specified, write it as a mixed number. You see how many 9s go into 40, that would be 4. 4 9s are 36, and remainder 4 left over, 4 9s. So hopefully a lot of you were correct. If you don't understand anything from this, always feel happy to ask any questions in the chat. And let me know what you think. But what we're going to do now is do another type of question of a past exam paper. This is from an edit, so style paper, and let's see if we can answer this correctly. If you were able to do the one we've just done, you should have no problem whatsoever with this one, because you only really needed to convert one recurring decimal. And actually, looking at this, you may not even have to try and simplify it. It may not simplify 241 over 3,330, but you don't need to even try to simplify, which will save you a bit of time in an exam question. You just need to show it can be written in that form. So this is off the GCSE higher paper from November 23. It was question 13 on paper 2. So let's have a look at this. So what we would do is, because it says prove algebraically, you would let x equals 0.0723, and the dots are important, they are above the 7 and the 3. But remember, the dots go at the start of the recurring part and at the end of the recurring part. So that actually means it's 0.0723, and it's the 7, 2 and the 3 that are repeating. So it'll go 723, 723. Again, just like before, because the recurring part is length 3 digits now, you need to move the decimal point 3 times to the right. So that's why I'm going to use 1000x. Again, if you want to get or move it past the 0 to use 10x and then past the 0723, you can do if you want. But that will mean using 10x and 10,000x, and it's a bit more complicated on trying to work out what to take away from each other by doing it that way. So I always say do it 1000x, do x, and then manipulate the fraction at the end, because people are usually more comfortable. Well, it's up to you which way you prefer. So 1000x, when you move the decimal point once, twice, 3 times, it would be 72 point, and then it will be 372, 372 repeating. And then let's just put x underneath it to show how it works. You've got 0.0, and then it's the 723, which are all lined up again. Because you had 3 digits repeating, if you shift it along 3, it's at the start of the next repeating part. And then you subtract them away from each other. You would get 999x, and everything, not everything after the decimal point disappears, becomes a 0, but when it's 723, 723, they all become 0. But you've got 72.3 when you take away would be 72.3. So you've got 999x equals 72.3, a terminating decimal now, and then divide by 999 to find the 72.3 over 999. Now, as I said, that's not a fraction and it wouldn't be an acceptable answer because there's a decimal on the numerator. So what I would do is manipulate that. Unlike last time where you can double the 0.5 to become a whole number, 0.3 is a bit more challenging. So you can just times the numerator and the denominator by 10. And what you're left with is 723 over 9,990 this time. If we look what we're trying to get to, it gives us a hint. Okay, 3,330. So that looks like they've divided the denominator by 3. So let's have a go at dividing the numerator and the denominator by 3. You wouldn't be able to spot this, and this is why they should say it's a show that question, because it gives you a hint on what to do next. Otherwise you'd be spending a lot of time to see if it cancels or simplifies. So the denominator is a bit easier. 999 or 9,990 divided by 3 is the 3330 like we want. And then you just have to do a bit of bus stop. Remember, it's a prove that, so you have to go into a bit more detail when you're showing something. So 723 divided by 3, use a bit of bus stop method. 3 into 7 goes 2, remainder 1. 3 into 12 goes 4. And then 3 into 3 goes 1. So yeah, 241 over 330. So that's the exam question for that particular question. Okay, for this live stream, I think we've done enough on the recurring decimals. If there's any questions, you can always message me on recurring decimals. But I'm going to open the chat to any other questions from any other topics you would like to discuss. Right, so let's see what we've got. There's not too many because I know it's getting towards the end of the academic year and people are slightly switching off, getting ready for the summer holidays. But we may have a go at one. Okay, so I think there's looking at there's an A-level question that's been sent to me beforehand that they like discussing, and they'll watch the live stream back and see my solution to it. So let's have a look at this. Right, so this one is to do with partial fractions, and this I would say is a very interesting topic for those students who are thinking about doing A-level, or those students that are halfway through the A-level course, just finishing year 12 and starting year 13, because partial fractions usually gets taught in the June or July of the AS course. Technically it's in the second year textbooks, but a lot of schools try and get a head start on the second year content before they break up for the summer holidays. The big thing to remember for partial fractions is, how does the denominator look? And here what we've got is, it's called a repeated root or repeated linear factor. So this repeated factor, you have to split it up into two separate fractions. The difficulty with this question is the fact that they've not told you how to write this partial fractions. Also, check if the numerator is at least the order of the denominator, or a higher order, because then it will be classed as an improper fraction and you may have to find a quotient before you split the rest up into partial fractions. Okay, but it's a lower power. There's a quadratic on the top, which is a power 2, and a cubic on the denominator, which is a power 3. So it's a lower power. So we don't have to worry about the even harder type of partial fractions. Lower power than denominator. So if you've done enough partial fractions practice, what you should think is, you can write 3x squared minus 13x plus 2 over x minus 2 squared, x add 1, and you do not write a whole quotient beforehand because it's not improper, but what you would have to do is do a over x plus 1, we'll do the singular bracket first, x plus 1, plus b over x minus 2. And then the last one, remember, if it's repeated, you have to do a factor for each power. So even if it was a power 4 on the denominator, you'd have to do 4 separate fractions, one to the power 1, the other to the power 2, the other to the power 3, and the other to the power 4. But this one, you do x minus 2 and x minus 2 squared. With all partial fractions, what you would do is multiply through by the denominator on the left hand side, And that would mean you would have 3x squared minus 13x plus 2. And that would equal a, but remember, a gets multiplied by, when you multiply through both sides by both x minus 2 squared and x plus 1, what you will see is the x plus 1 bracket would cancel when you times in the a factor over x plus 1, and then you have left with x minus 2 squared, and then plus b. One of the x minus 2 brackets would cancel, but you're left with x plus 1 times x minus 2. And then when you're multiplying out the c bracket, both x minus 2 brackets will cancel and you're left with c times x plus 1. Now it's up to you what you do next. But, okay, the easiest way to start is usually subbing in values of x that make the factors 0. So here I'm going to sub in x equals 2. And that would mean, because at A level you get a calculator every time, you would just check what 3 times 2 squared minus 13 times 2 plus 2 is. That would be minus 12 on the left. And the reason why you've chosen 2 is the A bracket you don't need to worry about because it's A times 0. Same with B, because that's got an x minus 2 factor. When you sub in 2, that will become 0. So you're only left with the C. So C times 2 plus 1 is 3, so you're left with 3C. And it implies that 3C is minus 12, so C would be minus 4. And that will be your first constant. Right, the next thing you would think about is subbing in x equals minus 1, because again, that would make one of the factors 0. So let's just check what subbing in minus 1 would do to the left hand side. 3 times minus 1 squared minus 13 times minus 1 is 3, add 13, and then plus 2 is 18. You get 18 on the left hand side. All we're doing there is the 3x squared minus 13x plus 2, you're replacing x with minus 1 on the left, and you're replacing it on the right. The reason why we're doing this is because we're trying to write it as an identity, so this function would be true for all values of x. We're not solving it for a certain value, it needs to apply for every single value of x. So, the b and the c terms are irrelevant now because when you sub minus 1 in, they become 0, or 0 times c and 0 times b, and anything times by 0 is 0. So all you need to worry about is the a bracket. So minus 1 minus 2 squared like that. So minus 1 minus 2 is minus 3. Square it becomes 9. So you're left with 18 equals 9a. And then that implies a equals 2. Right, and this is where, well, if it wasn't tricky enough, you've got to think about where the b values comes from. Now, again, because it works for all values of x, you can sub in x as equal to 0 and do it the same way as we've done before. But as you will know from all the partial fractions videos and lessons I've produced on YouTube or more on my website, what you can do is do something called comparing the coefficients, and you have to learn this technique for the improper fractions case because you run out of x values to sub in, and you always compare coefficients of the highest power. So the highest power in 3x squared minus 13x plus 2 is the x squared. If there's a higher power of x on the right, so say an x cubed, you use x cubed, so it's really the highest power throughout the entire equation or identity. So on the left hand side we have 3 x squareds, so you have 3 of them. but you have to have the same amount of x squareds on the right hand side. Now if you go back to multiplying these brackets out, x minus 2 squared actually becomes an x squared, a minus 4x when you've simplified, and a plus 4. So that bracket just contains one x squared, so when you times it by a, it becomes a x squareds. And if you notice, when you multiply these x plus 1 times x minus 2 bracket out, you get x squared again, you get minus x, 1 minus 2x is minus x, and then minus 2. It's the x squared we're needing, so it's b times x squared, so you have b of them. You don't need to worry about the c, because c is just multiplied by x's and constants, so you get a constant term and an x term, in other words linear. You don't get an x squared part. Right, so a plus b has to equal 3, so we've got the same amount of x squareds on both sides. You sub in the a equals 2 that you've already found, so 3 equals 2 plus b, and then b would equal 1. Because it said express it in partial fractions in the question, what I would suggest you do is always write your final answer. And don't just try and rush on from an exam question. Try and think, once you've found out the values, write your answer on the last line and circle them if you need to, the constants a, b and c, so it makes it easy for the examiner to mark it and make sure there's no marks dropped. Right, so how we would write it is something along the lines of 2 over x plus 1, because a is 2, b is 1, so it's add 1 over x minus 2. And then because c is minus 4, you could either put plus minus 4, or I'm going to write minus 4 over x minus 2 squared like that. And what you've done is written your answer, and that's called partial fractions form, because it's been split up into individual fractions with simpler denominators. A lot of them are linear, but as you can see, some of them, as the x minus 2 squared shows, can be quadratic factors, but they are definitely simpler than what you started with. Right, so I think that's all the questions that have come through. I'm just checking if there's any more. And hopefully these office hours live streams are providing helpful knowledge to you. If there's ever any topics you want to go through and ask me about, I will always be happy to answer those questions. As you know by now, all my office hours live streams are on my website or on YouTube. There's a lot more videos on my website if you want to access the members area. I'm happy to help, and the main thing is if you're prepared to work hard on your GCSEs or A-level revision, you will be rewarded when it comes to your final grades. Hopefully you're finding them useful.